In this example, we're going to take a look at what's known as the weighted mean. Now the weighted mean here, I have the formula up above here on the board. It's equal to the mean of one group times the sample size of that group plus the mean of the second group times the sample size of that group over the sum of the two sample sizes. Now this formula can be used for populations, as I have here, population mean 1, population mean 2, or it can be used for samples as well. And if you use it for a sample, then you would have an M here or an X bar, depending on how you represent the sample mean. Let's go ahead and take a look at a few examples of how to calculate the weighted mean. In our first example, suppose we have the first group has a size of 10, and the population mean for that group is 50. And the second group also has a size of 10, and its population mean is 100. Okay, so using these values, we're going to go ahead and calculate the weighted mean. So the weighted mean is equal to, we have our first population mean, so I have 50 times 10 plus 100 times 10, and that will be over 10 plus 10. And if you work this out, you should get 500 plus 1,000 over 20, or 1,500 over 20. I'm going to move to the right here to save room, which is equal to 75. Now notice for the weighted mean in this example, the value is equal to 75. And you should see that if you take the mean of the first group and the mean of the second group, we have 50 and 100 for the first and second groups respectively. Notice how the weighted mean is exactly halfway between those two means. Now this will always be the case as long as the sample sizes are equal. Now you may ask yourself, well, wait a second. If the weighted mean is just equal to the mean of these two values, or the middle of these two means, right in between them, then why do we need this formula? Why can't I just take the average of my two means every time? Well, the reason for this is, if we have equal sample sizes, you can do that. But if our sample sizes are unequal, then this relationship is no longer the case. The weighted mean will not be halfway between the two means when the sample sizes are unequal. Let's go ahead and take a look at that. Okay, as our second example, we will have unequal sample sizes, but we'll use the same means again. So I have N1 is equal to 10 with a mean equal to 50. But this time N2 will be equal to 20 with a mean of 100. So comparing these two examples, notice that in this second example, the only difference between the second and first examples is that the second group has 20 values in it, or 20 people's scores, or what have you, where in the first example, the second group had only 10. So let's go ahead and run this through the formula and see what we get. All right, so for our weighted mean, we'll have here, I'm going to take, remember, the mean for the first group times the sample size for the first group plus the mean for the second group times the sample size for the second group. So I have a first group mean of 50 times the sample size of 10 plus the second group mean of 100 times the sample size of 20. Okay, and that goes over the sum of our two sample sizes, which is 10 plus 20. Okay, and I got that, the 10 plus 20 from right here, 10 plus 20. So let's see what this gives us here. 50 times 10 is 500, and 100 times 20 is 2,000. So that should be 2,500 over 30, which is going to give us 83.33. 83.33, and you want to check these values on your calculator on your own. Of course, you don't have to do this in your head, and I don't recommend it because that's how we make mistakes. But check with your calculator on your own and make sure that's correct. Now notice in the second answer, 83.33. First of all, you want to ask yourself, is this halfway between the two means that I have here? Is it halfway between 50 and 100? You should see that it's not, right? Because 75 is the halfway point between 50 and 100. 75 is right in the middle. So, using the weighted mean formula in this example, we see that we don't get a weighted mean that's exactly halfway between the two means. So you should ask yourself, which of my two groups is this weighted mean closer to? Is it closer to the mean of the group with the smaller sample size? Or is it closer to the mean of the group with the larger sample size, the second group? And I think you'll see 83.33 is closer to the mean of 100 than it is to the mean of 50. So, what's happening here is the weighted mean takes into account the two sizes of the groups. So it takes into account group size. And the overall answer for the weighted mean, when you have unequal group sizes, the weighted mean will be pulled closer towards the mean of the group with the larger size. So here I have a mean of 83.33. It's closer to the mean of this group because this group had a larger size in it. It had more people in it. So as a final question, before we wrap up with this topic, I'd like you to think about what would be the case if, suppose, the group 1 had 20 and group 2 had 10 instead. So the group sizes were reversed. Group 1 had 20, group 2 had 10. If I have means of 50 and 100 still, and 75 is that middle point, should the answer be closer to 50 or closer to 100 if the first group had a group size of 20 and the second group had a size of 10? Well, you should see that it's actually going to be closer to 50 in that example because 50 would have had more people in it. So the weighted mean always takes into account your group sizes, and when you have a larger group size, the weighted mean will be pulled towards that group.